Okay, so now I'm going to talk about this transfer result that the transfer result. So this is this result that for this the finishing touch that is going to allow us to conclude that the Neron model is proper when for infinitely many m's, where m is co-prime to p, the residue characteristic. If that m torsion is unramified, right, then we're going to... Okay, that allowed us to conclude that the special fiber was proper. We need to conclude that the whole thing is connected. Okay, so again, we're going to take K over QP, an algebraic extension. And then R is going to be OK. And K is going to be the residue field. All right, and so here's the lemma. It says if X over R is a smooth scheme, over a discrete valuation ring, then the following implication holds. So if it's the generic fiber is geometrically connected and the special fiber is proper, this implies that X itself will be proper and the special fiber is going to be connected, geometrically connected. Okay, that's what we want to show. Okay, so there's two things that we have, right? So there's kind of here's the proof. Okay, so the proof involves two steps. So the first, we're going to say that geometric. So let me just remind you that geometric connectedness ascends. Okay, and so what does this mean? So that if K prime over K is a finite extension. I'm not even sure it needs to be finite. This is an extension of fields. And then if xk is geometrically connected, oh yeah, let's say finite extension, right? If xk is geometrically connected, so this implies that xk prime is geometrically connected. No, we need to do more than finite extensions. So, okay, so if this is geometrically connected, this is going to be geometrically connected. So it's stable under base change. So the point here is I'm trying to reduce so I'm going to be able to assume that R is a complete discrete valuation ring. Okay, and the other thing is that properness descends. Okay, so so I guess we could use like faithful flatness here. So if x over r, okay, so we'll do the same thing. OK prime is proper, then x is proper. Okay, so yeah, so these are the two things that we have. So with these two things, we can, without loss of generality, so suppose that K is a complete discrete valuation field. Okay, all right, or that R is a complete discrete valuation ring. All right, so this is what we have, and now I'm going to apply. So again, we're trying to prove that this. We're going to suppose these things, and then show that X is proper, and the special fiber is geometrically connected. Geometry. Yeah. So this is what we have, and so let me give you a fact. So let me tell you this fact that they use in the Serre-Tate theorem. They use the following. So they show that X can be written as the disjoint union of two open. So these are open sets. They're open and disjoint subsets where Z is proper over the base, and the special fiber is contained in Z. Okay, and so so by connectivity of X, so geometric connectivity implies connectivity. So the fact that X is connected, this implies that so that this thing is empty. Okay, so this was our fact. Now we're applying the fact, right? Okay, and then this shows that X is just this whole proper thing, and so hence X is proper. That's how we do this. All right, so we apply this thing where you can write X as the disjoint union of two open sets, one of which is proper and contains this proper piece. Okay, so the last part is okay. So why did we do this? So we did this because we're trying to get connectivity. So we're doing this to conclude the hypotheses of the Neron model, right? So the Neron model, we automatically have that it's a smooth group scheme. We don't have properness, and then we don't have the fibers are geometrically connected, and that's what we're really trying to do. We're trying to show that it's proper and the fibers are geometrically connected. Okay, and so the so let me just say what the Zariski's connectedness theorem is. Now we're gonna move this. So we're now kind of in the hypotheses of the Zariski connectedness theorem. All right, or this is a version of the Zariski connectedness theorem. It says that if this thing is geometrically connected, there we go. If this is geometrically connected, then sorry. This is what we're going to imply. Sorry, that's not what I want to write. I want to write the following. It says that okay, so it says that for let me put it in quotes. So for proper maps of nice schemes, so you can move geometric connectedness of the generic fiber implies geometric connectedness of the special fiber. Okay, so this is the idea. Okay, and so we have that so we are given. So we're given that that this thing here, K bar, is geometrically connected. And so we proved proper. We proved that it was proper. So this thing will imply that this thing here is geometrically connected. And so we've shown that all the fibers are geometrically connected. Well, I mean, I guess I could have written here xk is geometrically connected, and that's the same thing as xk bar being geometrically connected. All right, and so yeah, so that's how this part works. Okay, that's all I have to say about this. Okay.